Welcome to a new test and teardown video. This time it's a DC power supply from Soar Corporation, type 7400. It's just called DC power supply, and it's able to do 0 to 25 volts, 1.5 amps. And this one is in a mint condition because I actually bought this from new as a present to my father. I think it was like 15 or 20 years ago or something like that. It was a long time ago. But it's absolutely nice, super shape. So we're gonna play with this today and see if it's still up for the specifications. There's actually a few little things I want to show you about this power supply. So let's have a look. When I dial the voltage, you can see the meter here is updating really slowly, and that is super annoying. I would really like this to be like 10 times faster, so you could easily go where you want and then be done. See, it's about 1 time per second or a little bit faster than that, right? This is one thing I would definitely try and see if I can fix. Then listen to this. Click. Did you hear that? So about 13, 14 volts. There's a relay. So this is a transformer tapping, and this is a good way to maximize efficiency or lower the loss, lower the voltage over the series regulator. The heatsink is here. It's a very big heatsink, as you can see here, right? And the entire switch mode, this is not a switch mode, the entire power supply is very big. Look at the length of that. And it's quite heavy as well. So I expect there will be a very big mains transformer in this one. But the first little test, that will be, is the voltmeter a little bit accurate? There's only 0.1 volts resolution, so we can't complain about this, can we? And by the way, this one is brand new, just for the record. And what if we go down to, yeah, the voltmeter is definitely super accurate. Yeah, I'm super happy about that. So another fun thing about this, why only 1 meter? And then add all those switches and extra parts and all the stuff around that, instead of just adding 2 meters that will tell both the voltage and the current at the same time. That will be like 1,000,000 times better for the user, or for the science you want to perform using this power supply, right? So you want some voltage and then your current, and then back and forward here all day long. So, and you don't know your limit, you don't know what you're doing here, other than you have to crank this down short and then crank it up to whatever you want, 0.2 for example, and then it blinks because it's now in current mode, and now it is in constant voltage mode. So let's try and be in voltage mode and then try and short the output, and then the decimal point blinks in voltage mode as well, and then you go here and can see the current. So that is actually nice, and you know, oops, you need to check out the current. So it's not that stupid after all. So before we start loading this power supply, I'm just cranking up everything here at maximum just for the heck of it. So the idle power usage is 10 watts, and we are running a little bit low. Let's go to the official 230. And then it's 11 watts of idle. So let's crank up that is 1 amp of current. And the meter here is okay. So that means okay, that's quite all right. 10 milliamp resolution. And let's try and 1.1, 1.2, 3, 4, 1.5. That is the maximum official rating, and it is delivering 25.2 volts. So the output power is 37 watts, and input power is 68 watts. So that means, of course, the heatsink here will be warm in a minute. But how about we check? I think it's actually better to check the voltage, right? So let's do 1.6, 1.7, okay, 1.6. Yes, 1.6. That's what we're doing. And just to show you, I'm not completely lying here. We're doing 1.6, and the voltage drop is, of course, significant. And that is why, because I'm not doing voltage sense. I just plug this in here. I'm super lazy. I got voltage sense. As you can see here, the blue and the red wires. I don't know if that's easy to see, but I got voltage sense in here in the different parts of this hook. So we got current and we got voltage here, by the way. So that is really good when I'm doing all sorts of experiments. But the current is current, right? So it doesn't matter about what kind of voltage drop I got. It's still 1.6. So this amp meter is showing a tiny bit too much. And that is perfectly fine. All this works pretty good. And then all this works as well. Even at full load and all that. So how about we look inside? What is inside this thing? I've never been in this one before, so it's going to be interesting for me as well. But we better pull out the power cord. Always remember to do that, okay? So now we're inside. Like I said, this box is really deep and quite big. But it really didn't need to be that way, right? Because look at that. There's plenty of space here. And there's a lot of space here. It could have been a lot more compact. Because, I don't know, 60% of this case is air, right? So that will be the relay for the transformer tapping. And that was the rectifier. Isn't that a little bit funny to have the rectifier inside like that and directly up the capacitor? It could have been mounted on this piece of metal. That would have been a lot smarter, right? Then heat could have been, going all the way to the chassis instead of just having a hot spot in the middle. So that will be the emitter resistors for current sharing of the power transistors, and those are actually really cute. Look at that. So that's the output transistors. They're probably using this same case for a lot of different models. We also see this PCB. We got different parts that's not mounted here. There's a part down there. There's an extra relay. So I mean, definitely this reveals they are using this case for other power supplies as well. And you can also see the holes here in the bottom for transformers. Definitely you could fit in a lot bigger transformer in those holes, right? And that is the LED readout, and they're using this standard chip that's always used to drive LED segments and doing voltage or current or whatever kind of stuff. Today you can buy those tiny little LED displays on eBay for only a few dollars. And it could be really cool to mod this one. Remove all this stuff and put in 2 meters so we can read out voltage and current at the same time. That is definitely what I would love to do to this one. And there's another really cool thing about this, the whole case, the mechanical design here. You can probably see what I'm saying. This bottom plate here, if we take out those screws, perhaps we should do that just to show you my point. Because then we can easily access the bottom side of the PCB. While everything is still mounted, we can do service and repair and upgrades and whatnot, right? That is what I love about this case. And this is how you should always design your stuff. So you can go to the bottom of the entire PCB and perform service without dismantling the whole things and cables and PCBs and all that kind of stuff. And this is of course very important for somebody like me who's doing a lot of service and repairs of stuff. I just it always gets me, all this disassemble things. And here's the lid removed underneath the PCB, and now you see we can access everything nice and easy. We can see the mains input cord is of course with a ground wire. And what is that? That is not the correct one. I definitely would remove this one and put in a 3-pin. So we have correct protection. Yeah, that is nice. And the output from the mains switch, that will be the 2 white wires. And then they go, of course, to the fuse and then to the transformer. And that is nice. We can easily read the different voltages on the transformer, and it's super easy to reconfigure this for any other kind of voltage. Super nice, easy. Plus points for that. And that is the DC voltage output. Note the thin wires for the sense. That is the power output, and here is the sense. See again? So that is correctly made. Well done. And a tiny reverse diode. So if you put 2 of these or more of these in series, and one of them goes into current mode in an overload situation, then there is no reverse voltage input on that one because of that diode. And this is exactly why those diodes are always on DC power supplies, because that is how you blow them up. Yeah, I think that is actually what I wanted to do. This super short video about a little bit more modern DC power supply. Thank you very much for watching, and please come again tomorrow. Bye bye.